next one we're going to do is arc measure, the first one on the circles. Alright, so what is the arc measure of minor arc BC in degrees? So it wants to know, so the shortest distance from B to C, which that would be around this way. If it was major, we would be going this way, because that would be more area, but since it's minor, we're going to be using this angle, the closest angle we have to C. Alright. So first thing we know is BD is the diameter here. So this divide is 180 degrees. Diameter is 180 degrees wherever it's at. So we can use this part over here to find out what's left over here. So let's do 180 minus 155, and that will give us what these values equal here. So let's do 180 minus 55. 155, sorry. 25. So we know each piece here equals 25 degrees. So with that, we can say, so from B to D it's 180, so if we subtract that 25 we got, that will give us B to C. As you can see, we're just kind of cutting this piece off, if that makes any sense. So 180 minus 25, again, gives us 155. So this whole entire angle measure here is 155. Alright, so BD and AC are both diameters, so that's very helpful. So let's go ahead and mark those immediately. Let's mark the D and B one. So, what is the major arc of DBC? So it wants to know the long way around to hit both D, B, and C. So we would go to B, down to C. So what we want to exclude is this part right here. We do not want this shaded section here. We want everything else. And we know since these two angles are between diameters, that both on this side and this side, they have to be the same measurement. So literally, it's the whole circle minus 19 degrees. So 360 degrees in a circle minus 19 degrees. This whole thing is 341 degrees. Alright, here's more or less the same problem. So this wants the minor arc DC in degrees. So it wants the shortest way to get from D to C, which that would be, oh, right here. Oh, and look at that. They have to be the same because they're between diameters. So, 19 degrees. Alright, here's where it gets interesting. What's the arc measure? Major, BAD, on the circle. So it wants to go from B to A all the way to D. So this is perfect because we know that we want nothing to do with what's going on over here. This whole shaded region over here, it's completely useless. We don't want anything to do with it. So take the entire length of a circle, which is 360, and subtract these numbers over here that don't matter to us. So 360 minus 42 minus 74. And that gives us a length of 2 44.